Because that vessel is tiny, it has kept pressure pretty high. So pressure going into the glomerulus is under pressure for a reason. Under normal circumstances, not a problem. Chronically, it can actually burst the glomeruli, and they do not repair. All right, so here's what we need to happen. We need the blood flow to get to this glomerulus so that it can make its way through the nephron and have all the processes that can occur to filter the fluid that will get formed. And then I need for that clean fluid to go back to the bloodstream. So once the blood comes into the glomerulus and makes its way through the nephron, there will be an efferent arteriole, just like we see here, where the artery is small, the vein is large. It's the same thing here at the nephron. The artery will be large, the vein, artery will be small, vein will be large. It helps keep the blood flowing through it under pressure. Now, from the efferent arteriole, because we're going to have two types of nephrons, it can take one of two pathways as the blood leaves the glomerulus. It can go into peritubular, around the tubes that we're going to have of the nephron, to back to the cortex, which will be a vein there, or it can go into vasa recta, which is once again blood vessels. Okay? Either way, they're making their way back to arcuate, back to an interlobar, back to the renal vein, back to the inferior vena cava. The goal, hopefully, being that the blood that made its way to the kidney, went through the glomerulus, got filtered, and makes its way back to the heart, is now very clean to go back into circulation to make its way to all the organs of the body. All right? So, that is our glomerulus. Once again, it's going to be a part of the nephron. The nephron is the functional unit of the kidney. There's over 1 million per kidney. That's quite a bit. It's going to contain the part that is referred to as a renal corpuscle. So if we come over here, and if we try to look at the structure that we have, note blood flow going in, kind of, if we look large and small, keeping pressure up, okay, so that we can actually reach to this ball of capillaries, is what they refer to it as. See how they're trying to show a cutout portion and the red blood cells and the blood flow. And this would be the structures around these blood vessels. Okay? So what we end up having is this structure inside of a capsule. So everybody follow me. So this portion that has like our blood vessels, the wrappings around them, this is my glomerulus. It sits in a capsule. My capsule has a certain structure. My glomerulus has a certain structure. And the goal, push the blood through and be under pressure to push out the waste. So, at this point, when the blood reaches into this capillary system, red blood cells and stuff are not going to leave. We don't want that. We can't have red blood cells. If we get red blood cells in our urine, that usually means something's wrong. Okay? The goal is to push out, because remember, the blood coming in is going to be carrying all the waste. It's going to be carrying nitrogenous waste, urea, electrolytes, water, sugars, proteins. Do you see where I'm going with this? Because the blood is carrying everything. All right? So, the goal, even though not all of it that's in the blood is waste, okay? The goal is to get to a point where by the time the urine is formed, that it is just waste. So, molecules, particles, pieces that are small enough to make their way through these structures and become in, or get into this capsule, it's now filtrate. When the material that forms in my capsule, it is no longer referred to as blood, and it's not urine yet. The proper term is filtrate. And that's how it will be referred to. So, this structure where I've got my renal corpuscle, this capsule having all of these little blood vessels, the filtrate that it forms has to go into tubes, the tubes of the nephron. That's my renal tubular system. Something is going to happen at each point. In the tubes that will exist, I have a proximal convoluted tubule, the nephron loop, a distal convoluted tubule, and a collecting duct. So as the blood makes its way to my glomerulus, all right, as the blood arrives this vascular structure that is inside of this capsule, blood flows in, the blood leaves, okay? The vessels, they have their own protective structure, which affects filtration, okay? But what becomes important is, as the blood is moved through this vascular system, it pushes the stuff out. It's going to push out water. It's going to push out salts. It's going to push out sugars. It's going to push out anything that can make it through that vascular structure, or what they term podocytes, feet, okay? Around that vascular structure is what looks like feet surrounding it with little slits. So anything that can make it out of the bloodstream builds up in this capsule and is now filtrate. As it leaves the capsule, the first part of the tubular system that it encounters is my PCT, my proximal convoluted tubule. Is everybody following? At this point, the structure of the cells, simple cuboidal, one layer of cubes. These cells are excellent to allow materials to move. I just mentioned everything, not everything, lots of stuff gets pushed out of these vessels into the filtrate, but not all of it needs to become urine. It now becomes the process of returning materials back to the body. Is everybody following me so far? Okay, so this simple cuboidal epithelium with microvilli, as that filtrate passes over it, this is very good for helping push material because of the microvilli, and it's also good for absorption, moving materials. As it leaves the proximal convoluted tubule and it begins to enter what we know as the nephron loop, note that the structure of this nephron loop, it has a thick portion here, thick portion, thin portion. But also what we see how they're trying to represent this in the pyramid? They're trying to show that nephron, how it dips into that point of the papilla of that renal pyramid, which is located in the medulla, and then going back up, and this distal portion meeting a collecting duct.
Are there multiple of those systems in each pyramid?
Yes.
Oh, okay.
I would be afraid to say how many.
Okay.
Because if we have, let's say that if we did 1 million per kidney, and that kidney had 10 renal pyramids, that's 100,000 of these per pyramid.